Done.
Okay, great. Take
Great.
care.
Thank you.
Yeah.
Okay. Welcome everybody to this talk today by Ajay Pande on the future of software. A very interesting topic for all of us, I'm sure. Just to sort of start the program, I'll give a brief introduction to Ajay, although he's somebody who doesn't really need to be introduced to most of us. Ajay has been working on hardware design and software since he graduated with us in 1982 from IITK. The early part of his career was, spent in designing desktop and server systems, both the hardware and the software, along with their operating systems. Since then, he has been working on the development of both systems and application software. And for the last almost 23 years, he has been with Adobe, where he has led the product teams on several major products, including Adobe Acrobat, Illustrator, InDesign. He retired from Adobe last year. And when he retired, he was leading the team which was developing Adobe's cloud platform. So without any further delay, I'll hand the mic over to Ajay. And Ajay, I request you to please go ahead and start the presentation. Thank you. Just 1 minute. I request everybody to turn off their mics if they haven't done so already. Thank you. Go ahead, Ajay.
Thanks, Pankaj. Thank you for the introduction. Feels a bit weird. I think Javed Akhtar once said, after an introduction like that, even I want to hear what I have to say. So let me just I think the challenge with a subject as broad as the future of software is what you talk about. You can get into basically depth of the technology of how software is developed and sort of how it works currently, how it's worked in the past, how will it look like in the future. But I wanted to keep it fairly high level. So this is really more of an opinion. This is the sort of presentation that any of us can make. It's not particularly technical about software. It's a very high-level view of where we've been and where we are headed, with some attempt to say what it might look like in the future. And so if you've come here expecting to understand the detailed, complete future of software, you're going to be disappointed. In fact, I'm going to start sort of backing off from the broad topic right from the start. It's going to be a part of software, and it's going to be that part which is foreseeable. And that's because to start off on a presentation like this, you have two problems, or to use baseball terminology, two strikes. One is Yogi Berra's classical statement about the predictions. It's hard to make predictions, especially about the future. So we are going to talk more about how to make predictions about the future of software rather than actually make them. Well, maybe we'll make a few, but the basic idea is to think about the evolution of software, how it's got us to where we are today, and then what's the likely directions in the future given what we understand about that evolution. And then the second problem is that software really is too big a space to talk about. I mean, it'll become obvious from the fact, even when I talk about a very narrow segment of it, that it's such a big part of the world today that you can't really talk about software as a whole. So we have to focus, we have to reduce our scope so that we can meaningfully talk about it. And we'll focus on usage of software by everyday people in everyday life. There are obviously 100 or 1,000 different specialized use cases for software in industry, in space, in research. We're not going to get into details of any of that stuff. The idea is to talk more about software and the impact it's had on the world, and what's the direction of that impact going forward in the future. With that, is software a big deal? Is it really having an impact on the world? What kind of things have happened in the past, say, half a century? One of the things that struck me when I read this article about 12 years ago by Mark Andreessen, one of the founders of Andreessen Horowitz, he's a techie. He developed one of the earliest web browsers. This is before Netscape. And since then, he's been in the VC business, basically funding and supporting tech startups. And he had a pretty intriguing title, which is Why Software is Eating the World. And what the key question is, what does that even mean? What does it mean that software is eating the world? I think the key aspect of that is that things which were done using other means, other industries, other technologies, other ways of doing it are disappearing and are being replaced by software. It's not that software is eating the trees and the buildings around us, but it's eating up industries. It's eating up ways of doing things. It's replacing things which people used in everyday life with software. And to get an idea of what that looks like, we need to look back first before we look at the future. What did software look like, say, 50 years ago, a few years before we started at IITK? What did software look like at that point? And I think we all know what it looked like. We've been to the computer center somewhere around that time, or maybe a few years later. And so the key elements of software in those world wars, there was very few systems on which software could actually run. And certainly there was nothing like personal computers or even more so phones on which we run software today. They were basically large fridge-like computers, such as the ones we saw in glass-walled rooms in the computer center. They cost an arm and a leg, and there were only about a few thousand in the entire world. Sort of hard to imagine now, but this is basically the state of software 50 years ago. Software was not a part of people's lives. In fact, the vast majority of people would never have heard of anything called software. It's amazing that in 50 years, something people had, the vast majority of the world had never heard of, can become such an integrated part of everyday life. It performed very limited functions. It did a few things which basically you could call either numerical computations or what was called EDP, electronic data processing. And again, I'm simplifying a bit. Obviously, there are other things that software did as well. But in research and universities, such as IITK, bunch of what happened were numerical methods and computer science research. In corporation, what used to happen was what was called batch data processing, or back-end applications like payroll, inventory, accounts reconciliation. At the end of the day, you got a bunch of records. At the end of the week or the end of the month, you processed them and you produced a report, which was printed on a line printer. Now, don't get me wrong, software wasn't a dull, boring thing happening at that time. There was enormous excitement in the computer science research world. In fact, the 50s, 60s, 70s are the periods where some of the fundamental algorithms which drive computer science got developed, got discovered, got propagated. So it was a time of high excitement, but with a very narrow focus of computer science research. For the rest of the world, computers might have been interesting, they might have heard of them, but they were not a part of anybody's life. And few people, not more than 20 to 30,000, this is the best estimate I could find, did software for a living. And some of them may not actually have been full-time. They might have been doing it as a part of their other job or a part of their research. So you look at this picture and it basically says software wasn't really a big deal. I mean, nobody could have predicted in 1973, maybe some people did, but they were rare, that it's going to occupy the sort of position that it does in the world of today. But let's look at what that position is. And again, remember, I'm focusing, software today is too big a field to even talk about comprehensively. So I'm focusing basically on the narrow part of it, which is everyday software in everybody's life, not some specialized software, but what everybody uses. And this is what eating the world looks like. Just looking at the everyday experience of people, ignoring other places. In your house, you probably have something like 20 to 100 devices running software. Some people find that hard to believe, but if you start counting, just look at all the electronic devices that you have in your home. In addition, look at all of the appliances that you have in your home, the security devices, heating and cooling, fire alarms, media devices, and so on, entertainment. And again, obviously, my focus here is basically relatively well-to-do people in an advanced economy, but also people in other economies who are sort of part of the information world of today. And there will clearly be people who live by hunting or gathering, for whom this will not be true. But again, the focus is the mainstream. The focus is the mainstream business, commercial, economically well-off world of today, because that's what indicates what the future is going to look like. So the house is a hive bed of computing. There's software running all around you, everywhere. Then as a part of your life, if you want news and information, we know how we used to get that 50 years ago or even 40 years ago. It used to be through things like newspapers, television, radio. These are all giving way to online media and sometimes social media, all delivered by software. Information research that individuals do is digital, is run by software, starting with search engines. But even beyond that, hardly anyone visits a reference library these days in order to do research. You do it sitting at home using software. Entertainment's another huge area. I mean, these are all part of people's lives. Entertainment's another huge area. All of our entertainment is essentially becoming driven by software. It used to be that we went to watch movies, listen to records or cassette players, watch sports on television, so on. These are all becoming, I mean, we're still doing some of those things, but the formats, the media, the content is all becoming digital and controlled by software. Political and cultural discourse used to be mostly one way 50 years ago. It used to be media personalities, political personalities who used to do the talking, and we used to absorb it. Now everyone participates. In fact, most people would probably say too many people participate in it, and they want to prevent some people like me from participating too much in it. But there's clearly been a transformation on how politics and cultural discussions happen. Now, you could argue whether it's a good transformation or a bad one, but it's a transformation. News and political zeitgeist and cultural zeitgeist are often set on social media sites like Twitter. Elon Musk makes broad claims about Twitter being the consciousness of humanity, which is obviously hyperinflated. But the reality is that you often get news more from Twitter earlier and in more detail. And a day or two later, you'll watch it appear in various TV programs or in various newspapers. If you leave the house and travel around, you'll find that in your car has 3 to 10 devices running software. So you're surrounded by software as you sit in your car. Obviously, the car of 1973 had nothing to do with software. If you travel using other means, planes and ships are even more automated and even more fly-by-wire than cars are. And of course, the process of traveling is now completely driven by software as well. Another thing you do is communicate. That's a key human function. And again, in 1973, you would be using phones, you'd be writing a lot of letters. There were things like telexes. Sometime later, we got things like faxes. These are all converging to digital communication and digital content. Obviously, there's still many different forms. In fact, there are new forms which never used to exist. There was no such thing as social media until software came along. But basically, they are all of our communication is now driven by software. Work is another hotbed of software. I mean, all of our work is basically intermediated by software now. Whether it's the tools we use, the communication systems, the company, how a company controls the business, reporting, planning, these are all driven by software. And as a profession, something like 25 to 30 million people now do software for a living, as compared to 10 to 20,000 that I talked about. We do shopping as a part of our everyday life. We purchase a bunch of services. So obviously, we still do that in malls and in shops, but a large fraction of it has now become driven by software. The services that are delivered to us are now mostly software mediated. And lastly, government engagement. When we engage with the government in a variety of ways, such as getting services, such as even registering to vote, there's a bunch of areas where software, and actually even the conduct of elections themselves and how results are calculated is mostly driven by software. I mean, obviously there are other aspects of people's lives, and we'll talk about some of them later, but for the most part, large fractions of what we do in our life is now driven by software. Question is, what happened? What caused when such a large transformation happens that almost every activity we do uses and is focused on a particular technology or a particular industry? There's a natural question, what happened? How did it come to this stage, and what do we do? What do we look for when we look at the projection of that trend in the future? Obviously, a huge part of that, I mean, this is something everybody understands. I mean, there are many reasons. I mean, the one part of the reason is obviously demand. People want automation. People want electronic communication. So there's a massive demand for people if you can solve problems digitally, which were either not solvable or were expensive or had other problems earlier. But just staying on the supply side, why is it that there's so much supply of software in the world today when there wasn't almost any 50 years ago? A huge reason is what we all know is Moore's law, obviously, the explosion in semiconductor technology. That's what has made computers much faster, much cheaper, much smaller. The ability to put that in a little device on our wrist, such as this watch here, and so on. Now, I'm not going to get into any details of this. In fact, I'll give you a sort of a sneak preview. There's going to be a talk on the future of hardware, I believe next month, by Gopal. And I'm sure Gopal will get much more into the detail of what that revolution is. But that revolution has an essential part of what has caused the software explosion, what caused the software revolution. But there are a few other things as well. One is what I will call layered abstractions. And I'll spend some time talking about what this is and why it's important to the evolution of software. And then new ways of creating software. There are new methods today, and there may be more in the future, which didn't exist 20 or 30 or certainly not 50 years ago, which are driving the proliferation and the explosion in software. And so I'll start with number 2, because everyone understands number 1, and Gopal will do the talking on that in the future. Let's start with what I mean by layered abstractions. And to do that, let's try to understand how software actually runs. What is software at the core sort of fundamental near hardware level? What does software look like? Now, this is what is known as the von Neumann architecture, the design of almost all computers on which software run. John von Neumann, one of the most intelligent people ever, that's what he's called, mathematician in the early part of the century. Many people are disappointed. By the way, he made contributions to the Manhattan projects, and many people are disappointed that he was left out of the Oppenheimer movie because he was at Los Alamos and made significant contributions to the Manhattan project. But he's more known for his contributions to computer architecture. And basically, it has a very simple structure, and it might seem like, what's the big deal? But this is, people didn't understand that until von Neumann came along and said, this is how computers should be architected. So there are a few components. There's a CPU, which is where all the computation happens. There's memory, which is where you store a bunch of things, and then this is where programs reside when you want to run them. There's storage, which is so if you look at these, and again, I'm sure most people are very familiar with it, but I'm just trying to keep it simple. Memory is basically what you typically have today, 4 gigabytes to 16 gigabytes of on your phone or on your laptop. This is where all the programs run. This is where when something's running, you see things on your screen, this is where it is residing. And then storage is where is typically, I don't know, 128 GB to the 1 terabyte hard disk or other means of storage that you have, which is where all of your apps and your programs reside when they're not running. And then, of course, there's input output, which is things like the keyboard, the screen, the network communications, and so on. This is how things move around on your computer. And within the CPU, there's an arithmetic logic unit. And there is registers, which is a form of fast storage. You can think of registers like memory. They're just very fast. You can do things very quickly, but there are very few of them, typically between 8 and 32 registers inside a microprocessor. And obviously, everything that happens here happens in ones and zeros. Digital, everything is represented as ones and zeros. Numbers are represented with ones and zeros. Text, such as the text that you're seeing on your screen right now, is represented as ones and zeros. But also instructions or software, things that you actually run on that CPU, are represented as ones and zeros. And the typical instruction for a CPU like this will be something called move. So for example, you can move something from one register. You can move a number or a set of digits, ones and zeros, from one register to another, or from memory to register, or from input output to register, and so on. So there's a move instruction. Then there's simple instruction like add. You can add two registers. You can add a register and a memory location. You can compare two numbers if it is equal, greater, less. And then you can jump, which basically means you can jump to a different part of the program. And you can do a jump if the comparison is successful or if the comparison fails. This is the basic type of instructions with which software is written. So let's look at what
do this now.
somebody is unmuted. Can you mute? So this is what a program looks like. And actually, in the earliest part of my career, I wrote a lot of programs like this. I wrote, I guess, tens of thousands of lines of what is called assembly language, which is basically language like this, using the instructions which are native to that computer. It starts with a name, a label, a place called getKey. And it says move from the keyboard check port. So basically, it's moving a set of ones and zeros from the input output to a register called R1. So it's saying, check, there's a port in the way a keyboard will be designed in an input output system will be that there will be a port which will tell you, if you get data from that port, that data will tell you whether a key has been pressed or not. And that, let's just call it the keyboard check port. So it says read a set of bits or a byte from the keyboard check port into R1. Now check compare if R1 is equal to 0. So the way the keyboard might work is that if no key has been pressed, then the keyboard check port will return 0. So you compare R1 with 0 and jump if equal, get key. And if it is 0, you basically continue execution at the label get key. Now this is what is called a loop. You're basically going back to the move instruction again. So the two instructions, move a byte from input output to the register and compare the register to 0, will keep getting executed again and again and again, because so long as R1 is equal to 0, you will keep going back to get key, and you will keep executing these three instructions repeatedly until a key is pressed. When a key is pressed, the keyboard check port will return a non-zero number, let's say 1. Now, when you compare R1 with 0, it will not be, and so it will not jump to get key. And so what you'll get is the next command after the jump if, which is move keyboard port to R1. And so you're moving a byte from, not from the check port, but from the actual keyboard port, which contains which key was pressed. Obviously, keys are represented as ones and zeros. So there'll be a combination of ones and zeros for the letter A. There'll be a combination for the digit 1. But basically what you'll get is a digital number representing a key that has been pressed. And at the end of this program, R1 contains that information. So we've basically written a program which checks the keyboard, and when a key is pressed, it has that key available to you in R1. Now you can do other things with that key. You can continue the program. You can do more things. At the basic level, this is what a software looks like. In fact, software, no matter how you write it, ultimately gets translated to instructions like this, which actually execute on a system. Now, the question is, how do computers understand this kind of English language statements? Not quite English language, but these kind of statements. Obviously, these need to be translated into ones and zeros. There is a program called an assembler, which will take these English language statements or English-like statements and assemble them into ones and zeros. And those ones and zeros ultimately reside in memory, which is where the computer runs them. So this is sort of the fundamental of how software looks like. In fact, there's an interesting question here, which is, which came first, the assembler or a program? Because if you want to write assembly language programs, you need an assembler. But how do you write an assembler unless you know how to write assembly language programs? It's a chicken and egg problem. There's an interesting area of computer science called bootstrapping, which basically says you write a simple version of the assembler using binary, actually hand coding binary numbers. Then you write an assembler using that new assembler and so on. And at the end of it, you'll basically have an assembler which is written in its own assembly language. But I won't go into that details. Let's move on. Now, once you've written a program, you can convert that program into a function. It's the same program get key that we had written earlier. The only difference is at the end, I've got a statement called return R1. Basically saying whatever data you got from the keyboard, return that data. Now this get key now becomes a function. And somewhere else in your program, you can make a call to get key. You can say call get key. And what will happen is that the set of statements in get key will get executed, will get run, and the next key that is pressed will get returned as a part of that program. And so after the call to get key returns, which is it executes this statement and then comes here and then executes this statement. What I'm saying is compare if R1 contains the letter A. And so you've made a call to get key, which returned the key, and now you're comparing if the key that was pressed was A, and you can do different things depending on whether it was A or not. So you've converted a program into a function. Now you can use that function to build more functions. So here's a function called GetLine. It starts off by calling getKey, which will get a key. Now the key will come in the register R1. Now you move that to register R2. I'm sorry, that's not correct. R2 actually contains an address in memory where you want to put a whole line of characters, a whole line of that you have typed on the keyboard. So basically what you're saying is you get the key comes in the register R1, and you move that register R content of R1, that key, to a location in memory which is contained in R2. So the square brackets around R2 says, don't put it in R2, put it in the location pointed to by R2. R2 contains the address of that location. And then increment R2 by 1. So move R2 now points to the next memory location. And then compare R1 with enter. Did the user press enter, which means it's the end of the line. And if it is not equal to enter, go back to get line again, which means get the next character. So if you look at what this loop will do, this loop will keep getting keys, keep putting them in memory, keep incrementing the memory pointer so that the next key goes into the next location. So one character at a time, you'll start putting stuff in the memory locations. And then once it has got enter, it will not go back to the loop again. It will return the entire line. And then when you want to call getLine, you will put the address of the line in the register R2 because that's where getLine expects to find it. And then you'll call getLine. So now, if you look at the sequence of functions that we've created, Basically, what we are doing is we are creating new software entities or abstractions. This is what I meant when I say layered abstractions. So what software has done, what we've done here is that we've written functions which enable us to work with the keyboard as an entity. So far, the only entities we had were registers, memory locations, input, output. But now we can deal with keyboard as an entity. We can program using keyboard as an entity, which is what we just did. We can call GetLine, and we'll get a line of characters. So we've created a new abstraction. And obviously, there are many other keyboard functions possible. For example, is a key pressed right now? Was shift or control pressed when the key was pressed? And so on. Once you create many such functions and combine them, you get what is called a library. And we've created a keyboard abstraction so that basically now your software can deal with keyboard or keys as an entity. Computer software is full of such abstractions. Now we just created 2 or 3 functions, but then there are abstractions like UI widgets. If you look at your screen, you'll see buttons, you'll see scroll bars, you'll see text boxes, you'll see text. There are hundreds of different kinds of UI widgets, and these are created with literally dozens of layers of abstractions. You start off with the basic idea of writing a pixel on a screen, then the ability to draw a line, then the ability to draw a shape, then the ability to fill in the shape. Then if you click on a particular shape, generate an event which software can handle. So there are many complex layers which are built one on top of the other. But at the bottom level, it's still the assembly level and the digital abstractions that we described. And so what you're doing is in writing software is that you're building algorithms and data structures. Algorithms are the programs that you write. Data structures are these entities like registers, but also like widgets, also like a key or a keyboard, and so on. Now, how have these entities or abstractions evolved? What were the abstractions in 1973? What were the algorithms and what were the entities? Well, sorting used to be a very big deal. I still remember in my first job in the early 80s, computers were relatively small and had very little storage and memory. So even if you're trying to sort the records of a company's payroll, which contains a few thousand employees, it used to take an hour or more. And sorting was a really big deal. You took the records of all the payroll of the employees, you ran sort, and then you came back after 2 hours and found that it was sorted. Similarly, merging, which is you've sorted 10 different files, you want to merge them all together into a single sorted file. In more technical, this is typically what people did in commercial and business occupations. In more technical roles, what people did was basically numerical computation. So operations on matrices, Gaussian elimination, solution of differential equations or simultaneous equations. These were the typical abstractions of 1973 that people worked with. Now let's look at the typical abstractions people use today. Let's say you want to write something like a web browser. What kind of abstractions are available to you to write a web browser? These are the typical ones that would be available. So what kind of algorithm how do you write a browser? What does a browser do? A browser basically fetches a file using the HTTP protocol. That's what you type. You type HTTP in the address of a server. And your browser fetches a file. But the browser doesn't have to get into the detail of the network connection, how the bits are going from you over the internet to that device. You have an abstraction for network connections. It's called the socket library. It's available to programmers who write Chrome or who write Firefox. And they would use that to actually make a connection to a server and fetch a file. Then you need to understand user actions. The user is typing something, they're scrolling, they're clicking on a particular link. In order to understand what a user is doing, you need to be able to display widgets and then respond to events on those widgets. For that, you have something called a UI kit library. These are all Using the UI kit library, you can program using buttons. You can program using scroll bars. You are no longer programming using registers or memory. And then lastly, once it has understood the user action and fetched the file, it has to understand HTML, the language in which web pages are written, and it has to be able to display it. And again, there's a whole bunch of libraries available, including something called WebKit, something called Chromium, and so on, which will enable a programmer to display HTML on the screen. They don't need to dive into the detail of each HTML element and how to display it. Abstractions have come a long way from the much simpler ones like record of a user, text, matrices. These are much simpler abstractions, and the abstractions of today are much more complicated. And it is this process of going from simple abstractions to complicated ones that has enabled the explosion of software. Every language, every program does not need to be written from scratch. You can build on the abstractions that other programmers have written. It allows software to scale. The person who's writing the widgets is not the same person who is using the widgets to create a browser. The person who is writing the widgets is depending upon underlying software that has been written by somebody who wrote the operating system, which makes available the basic abstractions to display things on a screen, for example. So this creation of multiple layers building on each other is key to how software has become so vast and such available in such large numbers around the world. Now, if this is the process of developing software, where are we headed? Are there going to be a lot more abstractions, a lot more algorithms? What will software give us? What we are starting to see in the last 15 to 20 years is some slowdown in new applications. Most of the applications we use today, particularly at work, but often at home as well, probably started at least 15 or 20 years ago rather than being relatively new. Now, a lot of the excitement in software in the last 15 years has actually come from the phone, which is a completely new platform. But software on the phone is basically software on your laptop or software on your computer. It's still the same software, still similar applications. Now, obviously, the phone being a mobile device, there will be some applications which will be specific to its mobility, such as maps. But mostly, it's still the same software. Now, the other thing that will happen in the future is that hardware will keep making software better. It will be faster. If you're a game player, the realism in the game, the speed at which the game plays will keep improving because hardware keeps improving. If you're doing things which take a long time, such as machine learning, which we will talk about, you'll keep getting better because things keep getting faster and run in much less amount of time. But other than that, are we starting to hit the limits of where software can take us? Are we mostly done with abstractions and entities and algorithms? Is software sort of starting to mature, and are we hitting its limits? Here's an example of some of the things where we were hitting limits. Things have changed in the last 10 to 15 years, but these are big areas where we were starting to hit limits. Recognizing everyday objects in images and video. If you attach a camera to a computer, can it recognize the objects around it? Understanding spoken language, holding a conversation. These kind of things seem so natural to us, human beings, but they're extremely hard for algorithms. Because these seem so natural to us, there have been various attempts right from the 1960s to get computers to do them. It's generally been called artificial intelligence because the idea is that if software can do that, it is intelligent like human beings. But there have been several phases of artificial intelligence with relatively small amount of success over these 60 years. Because they've basically failed to handle these abstractions at a quality that they actually become in widespread use. There were programs to hold a conversation with a computer in the 1970s, but you'll try them a couple of times and say, yeah, that's nice, and never come back to it again. because I mean, it's just not that interesting. It's not that good. Object recognition in video and images was the subject of digital signal processing for a long, long time. But again, it didn't get to a point where in generalized everyday use by people, they were good enough. And then obviously there's another limit in a sense to algorithms that most people can't program. It's hard. The kind of things that I wrote there and doing that for tens or hundreds of thousands of lines of code is hard to do. And so most people can't write their own software. That also in a sense puts a limit to how much software growth can happen in the world. But then we come to the third element. I mean, I talked about three things which are driving software. One is obviously Moore's law and semiconductors. The second is the process of creating higher and better abstractions that other programmers can use. But then there are also new ways of creating software. I mean, some of them are obvious. I showed you a program written in assembly language, but nobody programs today using assembly language. You program using what are called high-level languages. You have all sorts of tools available to you to be more productive, to write software faster. But in the end, most of those tools are still basically developing algorithms and abstractions. And it's not fundamentally different from what engineers were doing in 1973. In fact, one of the things that developing higher level abstractions has definitely helped software engineers get better and more productive. But not the way of developing software. That has remained essentially the same in the last 50 or 60 years. But what has changed much more recently is the revolution of what we call machine learning. Vijay Saraswat talked about elements of that, but I just wanted to emphasize how fundamental this is to the future of software. In fact, to the extent that we understand it today, the limit that we are starting to hit in terms of algorithms and abstractions, machine learning is probably the one which is going to be, is already breaking through it and will continue to break through it in the future. And what we expect from future revolutions of software, the largest expectations are driven by machine learning. Now, what is machine learning doing? It is creating new software entities of the kind that we could not create before. It can recognize, understand, manipulate, and generate new abstractions. Not new abstractions like buttons and matrices and network connections, but abstractions like faces or everyday objects or English statements or voices and so on. And once you can deal with these abstractions, you can then program them to create basically completely new kinds of software which didn't exist so far. Now, the two big areas which have caused enormous amounts of recent excitement in this, one is obviously conversations. As I said, there have been conversational systems before. But in recent times, ChatGPT in particular has burst upon the world and has created enormous excitement. Some would say unnecessary hype, too much excitement, but there's no question that many people believe this is going to transform the world of software and applications. And actually not just software and applications, but many industries, how people do their job, how productive they are, how they learn, how they search and find information. What ChatGPT is able to do is two fundamental things. One, hold a conversation at a level a computer never has before. Being able to write, understand, and write documents at a level that a computer has never been able to do before. And third, to be able to apparently understand, we don't know whether it actually understands it or not, but apparently understand basically all the entities in the world. So whether you talk about chemistry or physics or law or art, it's able to hold a conversation on those subjects. It's even able to pass some exams in specific areas in those areas. And so clearly, this is a huge application of machine learning. The second is is an area called image generation. And there's an expectation that this may generate a large amount of at least commercial art in the future, things you see in ads. things you see in newsprint, in books, illustrations, images. An example of that is an application called Midjourney, and I've given a link to that. This is actually not a photograph. It's an image completely artificially. There is no such person. It is completely artificially generated using Midjourney. And the quality of such images in the last just a year or two has gone to a level where it's sometimes hard to say whether something is a photograph or it is generated by something like Midjourney. These are two major, obviously there are many, many areas of machine learning, but these are two particularly major areas that people have been excited about. Now, let's briefly talk about how machine learning works at a very high level. Machine learning is basically a sort, remember what we are trying to do. We are trying to do software. We are trying to, for example, look at an image. Let's take focus on that one. Look at an image and be able to identify if it's a cat or a car or a tree or a person and so on. You would normally, if you're writing software, what you would expect to do is you build an algorithm. You describe using instructions what a cat looks like. And so you say there's a line which goes somewhere up towards its ear and then down, and then the eyes look around. And in a sense, this is what people tried to do for many years in artificial intelligence and failed. Because we ourselves don't know what a cat looks like. We are not able to describe it in clear steps or algorithms. But we can do it. We can do it without actually being able to describe it. And machine learning is sort of the same thing. It's a mathematical model. You give I've created these nodes which are all connected to each other. Obviously, these are created using software. These are not physical hardware nodes. These are mathematical representations inside software, machine learning software. But basically what it does is, it does a computation on the input. So let's say at the input, you provide the image, the data of the actual image. And then you do a bunch of computations on that image in many layers. Obviously, this is 3 or 4 layers and 10 or 20 nodes. For recognizing an image, you'll probably need many millions of nodes connected to each other. This is one model of machine learning. It's called a neural network. There are many other models. But basically, these numbers, and in particular, these W's, these are called weights, the network. These are the parameters which control what calculations happen. And basically what we expect is that if you give it an image of a cat, at the end, after the many layers, at the output, what you're going to get is a number which represents the cat. If you get an image of a tree, you should get a number which represents a tree. And that is certainly possible to do. After all, if you look at the data, which is the data of an image, there is some function which, if you give it that data, will give you a number which represents a cat or a tree. You just have to find that number, that formula. You just have to find those parameters. And that is done in a process of what is called training, where you basically change these parameters W until for cat images, you start getting cat, for tree images, you start getting tree. So a mathematical model of machine learning basically gets trained. And the way you do that is that initially the weights are all wrong. You give it a cat image and you don't get a cat number at the output. But what your algorithm knows is that in order to get a cat answer on this particular image, I must change W1, W2, W3, and W4. And if I change them in this direction, then it will output a cat. And so you change the W's a little bit so that it gives a result which is more like a cat. Then you give it another cat image and again adjust the W's. If you do this millions of times on millions of cat and tree images, the incremental changes in the W models ultimately results in a network which has been trained. It now knows that if you give it a picture which contains a cat, it will output a cat. So in a way, basically what you've done is you've written a program without writing a program. There is no program which has been written which identifies a cat. It's just a network which takes as an input a cat image and outputs a cat, a number which is a cat. but that has happened by learning. It has slowly understood by changing these weights, how to actually do that. Now, using this, what does ML mean? So obviously I've given a highly simplified version of what this looks like. But now getting to sort of the future of software, and clearly the future is highly dependent on where ML takes us. What does ML mean? So basically with large language models, which is what Vijay talked about, one impact on the future of software is that with LLMs, there's actually now a new way to program. You can give instructions to ChatGPT using English. So in that sense, English or actually French or Hindi or any language, because it understands almost all languages. And so if you can give instructions to, for example, you can say, go look for this piece of information, convert it into this format, and then lay it out in a document in this structure. That's the program. And so in a sense, this may open the opportunity for everybody to program. All of us need certain research, numbers, tasks to be done. And if we can do it using natural language with a program like ChatGPT, then we all become programmers. And we can write our own software instead of depending on other companies to give us software. So that's one impact of machine learning. But then the other impact is that it creates new kind of abstractions and entities, such as I said, English sentences, historical events, philosophical ideas, objects and images. If it can deal with these abstractions, then you can program using these abstractions and create completely new kind of programs. And in theory, if it can deal with real world objects, it means that it can automate everything. If it can understand, like people, what those objects are, then it can do the things that people can do. But then the question of the future, is the answer just that the future is simply, it will do everything that humans can do? Well, in the long run, maybe. In the foreseeable future, the question is, how good is it at working with these abstractions, these entities? There's a fundamental difference between the kind of abstractions that we used to use in algorithms and data structures. Those abstractions were perfectly defined. The idea of a line of characters or a button on a screen or a network connection is defined precisely. It is perfectly defined. And when you write a program using those abstractions, the program will get it right every time. I mean, obviously there can be bugs in your programming which can cause problems, but fundamentally you can write a program which will deal with all network connections of all types perfectly without ever getting it wrong. That's not true of machine learning. When you're training a network, there will always be cat images which it will not identify as a cat. For example, the cat may be facing backwards, or it may be in a corner, or it may be defocused. There may be all sorts of reasons why it will not identify it as a cat. So it's not perfect. Unlike earlier abstractions, machine learning abstractions cannot be dealt with perfect. And so what is it good at? And once we know what it's good at, maybe we can make forecasts of what software would look like, or what it can do for us, or what it can do to us in the future. So how good is machine learning? Now, if you're recognizing objects in limited domains, it knows the environment it is in, and it's trying to understand what are the objects around it. It's very good at that. I'll give examples. When I talk about these things, I'll give examples of some of the leading edge areas. Obviously, one big leading edge area is self-driving cars. If you look at, if you have a self-driving algorithm in your car, and you look at the screen while you're driving, it is identifying pedestrians, cars, trucks, motorcycles, buildings, crossings, red lights. In that limited environment, it is extremely good at recognizing those objects. Recognizing dynamic objects, objects that might be changing, moving around in unconstrained spaces. You could be in your house, you could be in a mountain, you could be in a jungle, you could be in a road. It's poor. Programs which can recognize dynamic objects moving around anywhere basically don't exist. Maybe they will, but today it's poor. Till a year ago, or at least 2 or 3 years ago, you could have said that holding a conversation, it's like average, maybe starting to get good. But since ChatGPT 3 and in particular GPT 4, it's excellent at holding a conversation. It can talk about any subject and it will give coherent or mostly accurate answers on almost any topic in the world. If you look at the idea of actually manipulating physical objects, and this contains multiple things. This contains the ability of physically having a robotic arm which can grasp an object, of being able to visually see the object, being able to manipulate it, do things with it. It's happening, it's starting to happen in factory automation and places like that. But again, comparing to human beings, it's pretty poor. Human beings are outstanding at manipulating physical objects. Software is poor. Again, navigating complex spaces, if you're walking around and there are objects in between and you have the rocks that you have to climb over, steps that you have to negotiate. Again, there are some companies like Boston Dynamics in particular, which has robots which are starting to get very good at this. But on the whole, it's average to poor. Understanding human psychology, it's actually, now again, these are debatable. I'm sure there are people around who will disagree with me on some of these things. Understanding human psychology, I'd say it's extremely poor. These are not crafty, manipulative, smart programs, even ChatGPT. They're not able to manipulate people. They don't understand people's psychology. They don't understand what people want. Logical reasoning about the real world. It's getting there, but I'd still say it's pretty average. Being able to for example, there's a standard question puzzle we've probably all done of 20 questions. It's a game we've all played, where you try to identify a particular historical personality, well-known personality, by asking 20 questions of them. If you ask ChatGPT to play that game, it understands what you're trying to do, but it's terrible at it. And mostly it will never get there in 20 questions. It asks very bad questions. You can clearly see that it is not thinking logically in a way which will enable it to actually identify quickly what to eliminate, how to frame a question so that you eliminate a large part of the choices and focus on the choices that you're trying to get to. Arithmetic and simple math, it's average. I mean, it can do computations, it can do some physics problems, it can do some math problems. If you ask it a practical question which involves some arithmetic, it will be able to do it mostly. But if you talk about what mathematicians actually do, prove things, analyze proofs and things like that, it is poor. It does a really poor job of that. It's not a mathematician, not even close. And then finally, following instructions involving real world entities. I mean, if you want to deal with real world entities, human beings should be able to instruct machines, follow instructions. And there it's starting to get quite good. And the prime example of this is, again, self-driving. I mean, dealing with the entities that we talked about, roads, pedestrians, traffic lights, GPS, and so on. It's able to do a pretty good job of following instructions, of taking you from point A to point B. It's not perfect, but it's pretty good. Finding and analyzing information. I mean, a lot of people, including me in many cases, have started to use ChatGPT instead of Google because it understands what you're looking for and will give you a targeted answer. And so it's getting very good at finding it and then being able to analyze it. If you give it information, ask it to summarize it, to comprehend it, to answer questions about it, it can do a very good job of it. You give it a legal passage and you ask questions about that legal passage, it will give you great answers. But, and this probably makes us feel good that it's not quite getting to our levels. Again, they get there, but it's not there today. Now, given these set of capabilities, what can we say about what ML is likely to do in the foreseeable future, either for us or, as they say, to us? What human sphere is most likely to be affected by ML? Now, if you look at areas like analysis and diagnosis, very digital data, typically represented by looking at an X-ray and being able to make analysis, or looking at other radiological reports and being able to make a diagnosis. It's very good at analyzing information. You give it information and you want to make a summary or analysis, it's very good. It's not great at making high-level connections. It's poor. But given that it can analyze information well, the likely impact to diagnosis with digital data is going to be significant for our well-understood conditions, which is routine work for, say, a radiologist or a pathologist. I think this will have an impact. A lot of that routine work will basically get farmed out, at least at a first stage, to ML algorithms. Now, there's something which a lifetime of experience tells a radiologist, which is, how did this happen? What caused this problem? What they don't just identify a condition, they also talk about how it happened and why it happened. And those require the kind of connections which it is poor at, and it probably won't be able to do that. Legal services, another area. It's excellent at analyzing information. It's not bad at logical reasoning, but there are some areas like deciding legal strategy. How should you go about pursuing a case? There it's going to be poor. Making connections with other areas of legal jurisprudence, again, it's not going to be great at that. But there are a large part of what the legal industry does, including routine research, summarization, at which it can be really good. And these are likely to be heavily affected. Litigation, probably much less so, because it involves things like strategy and constructing new arguments rather than analyzing existing ones. Self-driving cars we talked about, and it's another promising area. And I know there are probably people on this call who will disagree with me, but in general, I think we are getting there. It's very good at recognizing objects in limited domains. It needs to be even better. It needs to be perfect or near perfect, and it's not there as yet. And it's pretty good at following heuristic directions. So I expect that this will happen. A particularly exciting area, which may be in the near future, I think, is domestic robots. I know Tesla is working on it. I know there are other companies working on it. Objects in limited domains, it's very good at understanding. I don't think it will have any trouble at understanding the kind of objects that are in a typical home. It's poor at manipulating physical objects, but then you may not need that complex manipulation in a home. Turning on, say, a heater, or opening the fridge door and taking out something so that you can mixing a few food ingredients together may not require the most complex of physical manipulation. But the potential is huge. And of course, following directions, it should be pretty good. I mean, conversation, it's excellent. Voice recognition is excellent now. So it should be able to follow basic directions. So this may be a particularly exciting area that's coming in, I mean, who knows how long, but certainly the next 10 to 15 years. The trades, and this is an American word, but which basically means people like plumbers and electricians and construction workers and so on. The only part of that which it can possibly do is recognize objects, but it's very poor at everything else. Navigate, I've done a bit of DIY stuff in my own life. And one of the things that you learn very quickly about the job of an electrician or a plumber is that a big part of it is getting into very difficult spaces and being able to manipulate objects in extremely complicated ways, such as those two spanners that you see manipulating those pipes. And similarly, you have to get into tough spaces. You have to manipulate things in complex ways. And I expect it to be a very long time before AI software can actually do that. And so it's a bit surprising that you would expect that something which is a physical task should be automatable and these trades will be under threat. But actually, the reality is the other way around. It are tasks which involve digital information, such as legal services or diagnosis, which may be affected much more than the trades. And then the ultimate worry, will AI take over or destroy us all? I mean, we've seen a lot of speculation in these areas, a lot of worry. There are even people who are recommending that we stop doing AI software until we figure this out. And frankly, I'm not worried. these things are, I mean, in order to take over the world, you need to have really good logical reasoning, and it's not very good at it. You need to understand human psychology because humans are what you're going to be up against. And again, it's poor at that. It's not great at physical terrain and physical objects. It's poor at strategy. I mean, how do you take over the world if you can't even build a good strategy? And then most important is we assume that these things will have their own goals and their own desires and wants. And there is no sign at all that they have anything like that. And so I'm not worried about it. Now, apart from sort of some of these projections, what these foreseeable projections, what are some of the things which are maybe not so foreseeable? Or some people might say they are foreseeable, but at least we are not sure about them. We've seen how smart ChatGPT 4 is. The question is, how smart will ChatGPT 5 will be whenever it comes out? We talked about neural networks and nodes or parameters in those neural networks. I believe ChatGPT 4 has something like 200 billion parameters. What happens when ChatGPT 5 has 2 trillion or 5 trillion? Now, there is some indication based on the progression from GPT 1 to 2 to 3 to 4 that there is a threshold of the amount of parameters that a neural network has beyond which its capabilities take a sudden jump. Clearly, a big part of why GPT-4 was so much better than GPT-2 or 3 was that it used 200 billion parameters. Is there going to be another big jump? And some of these areas, such as logical reasoning, strategy, are all going to appear once we get to 5 trillion nodes? Maybe. Nobody really knows the answer to that. Some people speculate, but nobody really knows the answer. Now, what we do know is that it cost OpenAI, I don't know the exact number, but somewhere between $10 and $100 million to train ChatGPT-4. And if you are going to do 10 times that training or 10 times that number of parameters, you might need 10 times that much cost. Costs in computations have come down, but they're not coming down all that fast. And so if you're going to do 100 times that computation, you're starting to cost billions, number one. Number two, even when you type a question in ChatGPT today, it responds at a certain speed. Now, if you're going to have 10 times as many parameters, your speed is also going to come down unless the computation of even delivering the results of the conversations is much higher. And so I think there are people who are saying there are some limits, at least currently for the next 5 or 10 years, to our ability to scale this well beyond what ChatGPT-4 does. We don't know, we'll see. GPT actually got created using a particular AI architecture or machine learning architecture called Transformer. Are there going to be new, that is, Transformer is what created the huge ability that ChatGPT has. Question is, are there going to be new architectures which are much better than Transformer? Again, nobody knows. This is unforeseeable. And then for about last 10 or 20 years, many people have been talking about the singularity, where once AI gets to a certain level, it can make itself better. It can look around the world, teach itself, and keep getting better until a point where you hit a singularity where it basically knows everything and can do everything. We don't know. These are all open questions, and maybe we can chat about them as we go along. And then, of course, there are the big social questions around AI and what it can do, depending upon how big an impact it has. If AI is able to automate large parts of things like factories and creation of goods and services, then who owns them? If you're able to sit at home and get all of these things delivered to you by automation, well, who owns them? Should I get it delivered to me? Which ones should I get delivered versus somebody else? Who owns an automated world? I mean, the natural answer is whoever owns the robots, because they are the ones which are creating these goods and services. And so whoever owns them owns the world. Are there other answers? These are open questions. If everything is done for you, then what do you look for? What's your life like? Why is it even interesting if everything is done for you? And then whether it's going to be good or not, whether there are going to be problems or not, what should people do to prepare? Who will do well in an AI-driven world, and who will suffer or who will not do so well? And so, what's the message for our children and grandchildren? And that's it. Thanks for your time. Thanks for listening patiently. Let's open it up for discussions.
Thank you very much, Ajay, for that lovely talk, for the very interesting talk. There are a couple of questions which have been posted on the chat board. I'll get to them. But before that, I'd like to inform everybody, and I'd like to welcome Professor P.R.K. Rao, who's also been listening to your talk. He's there with us, and this entire group is honored, Professor Rao, to have you with us this evening. I have, of course, met you recently, relatively recently, but I'm sure many of the people who are attending this talk are possibly seeing you after a few decades. It's a real honor for all of us to have you in today's talk. And if you don't mind, I'd request you to say a few words about what you've been doing and how you're keeping. I'll get to the questions, but you'll have to unmute yourself, sir. You'll have to unmute yourself.
Yeah, it's
Yeah, I
pleasant
think
to
that's-
meet you all, and in particular Ajay, whom I still remember
Absolutely,
very
sir.
much.
Very much so.
Well, I belong to the Paleolithic age, so I am 1 foot in the grave, anxious to put the second one. But I have been fairly, not so much physically, but intellectually still active, keep pestering people with all kinds of mails, this and that. I've taught a couple of years at IIIT Hyderabad, where Rajiv Sangal was the director. He had requested me, why don't I come and have some more victims? I said, yes, okay. It's always a pleasure to have victims. So that's how it was. I met Gopal Raghavan recently when he came to Hyderabad. He came to Hyderabad to visit me, in fact. Then Pankaj and we met. There are a couple of, there are, I think, about 8-10 IIT students of that vintage in Hyderabad. And Anil Tandon, for example, A.P. Tandon is one person who is here. And of course, Rajiv, until recently, was here. So that's how it is. Where are you, Ajay? In which part of US you are there?
I'm in the Bay Area, San Francisco Bay Area, sir.
Bay Area. Okay. Yeah. My daughter is actually in US. It was Seattle. Her husband works for Microsoft there.
Okay.
I haven't gone there after they had gone there, but that's how it is.
Do you come to the US?
I think Koteswar Rao is also in US, I think. Like
Yes.
Koteswar is also your batch.
Yes, he's in
Number
Houston.
five.
Yes, he's also in our batch. In fact, he had attended 1 or 2 of the previous lectures. I don't think he. Are you there, Kotesh?
No, Kotesh is not there today. Thank you very much, Professor Rao. It's been a pleasure, I'm sure, for all of us to see you after so many years.
Yeah, it's good.
Ajay, I'll get to some of the questions which have been posted. Murli has asked, how does embedded software which is used in the automobile modules work? So if you could give us a brief idea about it.
I'm trying to understand, Ajay. I work in auto industry, and last 3-4 years I've been working in electrical modules. So essentially, the software which goes inside something like they call, for example, it's called LDM. Okay, light display module. Okay, where basically you give some input, which would be a stick, like a button, and then the output would be a light. So I'm trying to understand how that embedded software creates this relation between input and output. I'm a novice to software. I'm just trying to learn. Thank you.
Yeah, I mean, if you saw sort of what I described as the von Neumann architecture and the basic idea of how software works, it's the same thing in embedded software. In the end, software is always the same thing. The difference is in the case of the design that I showed, I talked about IO ports, which were things like keyboard or display and things like that. Whereas in embedded software, like in a car, the ports will be things like speed or an output port, which allows you to turn or fire the spark plug or do a fuel injection or something like that. So instead of dealing with things like keyboards and displays, embedded software deals with entities like speed or spark plugs or things like that. Basically, there's analog to digital converters, which convert sensors over to digital. And once they are digital, a CPU can manipulate them. Once they are numbers, and then it can send digital output, which will control actuators, such as to turn the steering wheel or to fire the spark plug. So it's exactly the same as what I said. The numbers it deals with are just different from what a standard laptop or a phone deals with.
Shailesh has asked a question. It appears from your talk that machine language is the same as AI. Is that true? Or if not, what are the differences between the two?
Yeah, so they're not necessarily the same. There are ways of doing. Artificial intelligence is just trying to do human things using computers. That's the definition of artificial intelligence. Machine learning is a particular way of doing artificial intelligence. As I said, right from the 60s, people have been trying to do AI by using algorithms and abstractions the way I described. They just haven't been that successful until machine learning came along as a technique in the last 20 years or so. And it's become so dominant as a technique that now when people speak about AI, it's often almost always machine learning, but they're not fundamentally the same.
Nitash has a very interesting question. Is there any hope that AI will decrease inequality at some point? Or will the world likely become increasingly a place where only folks like you can thrive?
Well, I remember I said whoever owns the robots is going to own the world, not the people who program the robots. They're workers like everybody else. But this is really a question for us. this is a question for social policy. It's not a question for AI, obviously. This is a huge subject. This is not what we can talk about is what kind of things AI is going to make happen. One of the questions that we talk about is how, the last question I had in there was, who will succeed and who will not succeed? How do we prepare ourselves? I think the key thing that the young people in the world should be doing these days to prepare for a career, one is learn to program. Everybody who's a young person, if they can, should learn how to program. And second, they should be engaging with conversational AI. They should be understanding, because conversational AI, like ChatGPT, is just going to keep getting better. People need to understand how to use them in their work and in their life. So I think these understand how to use software and programming and AI rather than have it do things to you, I think is the biggest deal. But in the end, this is a political question. I think there will come a point where there will be a real question that there are no jobs available because everything can be done by AI, or very few jobs available. Then who owns the world and who gets to thrive and who doesn't? I think in the end, it's going to be a political question.
Bala has a couple of questions, Krishna Bala. The first question is, he says the word is that OpenAI spends about $500,000 a day on free ChatGPT services. Is this sustainable? This is his first question. And he has another question, which is there any word on the developments in human-computer interconnects? Something like mind melds.
Yeah. On the first one, Yeah, I mean, OpenAI is spending a lot of money on the free part of it, but I mean, that's been a model for software companies forever. When Adobe spends a lot of money on free Acrobat Reader, which everybody downloads and everybody uses, but then there are other sources which are enabled by those free downloads, such as the paid Acrobat product, which make way more money than Adobe actually spends on the free Acrobat Reader. The $20 a month subscription price for ChatGPT, which is, I subscribe to it, I know many other people do as well. My guess is that it's more than making up, because I know there are a large number of companies which are giving a significant number of their employees paid ChatGPT connections in order for them to understand how to use ChatGPT as a part of their job. So we don't know the financials, they haven't declared them, but I expect that they'll be making more from the paid services than they are spending on the free service.
The second question was on the human-computer interconnect.
Right. I think the one that I know most about is Elon Musk's Neuralink. I think they are doing serious work on being able to basically tap into the neural signals in the human brain and then be able to use those signals to do things like help perception, help sensors. Basically, if you don't have a great sense of hearing or sight or touch, it can potentially provide some of those sensors to you, as well as motor functions. It can use mechanical devices controlled by your brain to be able to drive it. So in terms of exactly how far along they are, I don't know, but it's certainly something that they're working seriously on. And it's one of the areas. I don't know if there are others. Has anybody heard of other companies doing that?
There are DARPA projects, at least there were a few years ago, that were basically, trying to deal with injured soldiers and helping them through brain-machine interfaces. And there are several other, with spinal injuries and stuff, but I haven't heard of anything that I believe is truly close to anything, that could be widespread. One of the issues, of course, is, in medicine, doctor do no harm, and to insert electrodes into somebody's brain without potentially impacting is a huge hurdle. So that, if you're unhealthy and you can't move any limb, of course, you're willing to try this. But for otherwise healthy human beings to want to insert something, invasive electrodes into the brain, I think will remain a potential hurdle, and finding ethical doctors who are willing to do this, etc. So, but who knows?
Girish Netke has sent a message on the same topic, which is that the gaming industry, it seems, has been working on human interfaces for several years. I don't know whether he means interfaces in which there is some sort of a meld between the human brain and the machine. But I think that's what he seems to be implying. Sanjeeva, I saw your raised hand. You just wait for a minute. I'll come to you. If you just wait for a minute, I'll just finish another question. Sanjay, you were talking, you had raised a couple of questions. Go ahead and ask Ajay.
So Ajay, one of the things that struck me in your very interesting talk and thought-provoking is you said ChatGPT, I would say came as a surprise 3 years ago, right? That people weren't anticipating the ability to carry on a conversation with a computer on anything across the world. And my question is, were there any telltale signs of something that we were close to it, or did it come as a complete surprise? And the reason I ask is there is a whole host of things that you listed as AI being currently poor at. And I'm wondering, is there something that suddenly says, well, it was poor, but today it changes everything? Are there some areas where we see stuff going on? And I'm not, active in software, et cetera, or following what's going on in the world, but are there any telltale signs that show signs of anything? One of the areas I asked about was activity recognition. Images are, after all, image recognition is mature, but activity recognition is very poor, which is, a video is just a series of stills, if you will, in the simplest terms, but we can't do it. And so are there telltale signs of something that says, it's poor now, but we are close to having a fundamental breakthrough or a scaling breakthrough that will solve these issues for us?
Yeah, I mean, the way to think about that is to look back at telltale signs of ChatGPT. What were they and when did they appear? And I think if you look at it, outside people who were working in NLP and basically conversational software, there weren't really any signs. You have to be in that domain, you have to be in that field to understand. But the transformer caused the transformer, and basically what the signs were in the research papers, which were showing better and better results on benchmarks related to conversations. On GPT-1, on GPT-2, by the time GPT-3 came along, the broader computer science industry was very familiar with it. And then when ChatGPT came along, the world was very familiar with it. So it's in the research papers. It's, again, not something that I actually follow. Now, Sanjeeva is actually here, and maybe he can speak to it. I know AI is one of your interests, Sanjeeva. Which places are starting? First of all, do you disagree with anything I said in terms of poor, average, and so on? And then, are there any particular places which are showing signs of transforming?
Yeah, Ajay, you're putting me in the spot. I'm actually an AI skeptic, and I really don't know much about AI. But let me just sort of weigh in on several things you said. No, I don't think I disagree with stuff that you listed and what machine learning is good at and currently good at and currently poor at. I think you're much more informed than I am on it. I actually have not. I've held out and not tried playing with ChatGPT till date, which is, I think, criminal on my part as a professor of computer science. There are a couple of things which I thought. I mean, I had 4 points which I just wanted to, and I'm looking at slides 23, 25, 27, 29 of yours. Let me just sort of say, what should be the equivalent of a Turing test for machine learning, right? Could machine learning in its current state look at all the data that Tycho Brahe looked at and come up with Kepler's laws? That would, I think, be really saying that it's able to distill intelligence from data. That's the kind of test that I would put, machine learning to it. I heard a very, very interesting talk many years ago. It's probably 7 or 8 years ago, from Adnan Darwish, who's used to head the department at UCLA, and where he was contrasting artificial intelligence with what he called animal capabilities. The ability of an eagle to detect movement of a mouse at a very, from a very far distance, which is way better than what human beings can. And we are better than animals in some respects. Animals are much better than us in some respects. And it's the same story with software. I think what is interesting, and I think this is a beautiful point you brought out, is that the so-called physical things like, how to fix your plumbing is actually harder for machine learning in its current state and artificial intelligence in its current state than human beings, than people who are not, you wouldn't think they're very high on the IQ scale, but they're much better at actually manipulating. And I think you mentioned this quite nicely in one of your slides, which is the abstractions. Human beings are great at building the right abstractions, and the abstractions that we've been playing around with and feeding these systems on which we are training may or may not be the right ones for various things. For example, we're training machine learning software on various images, self-driving cars on various images. we are not training them on the invariance that physical reality has. You suddenly cannot go and, change an image of this kind which you're perceiving to something which is very different. So I think maybe we are training them on the wrong things. We're using way too much energy and time and resources in training them on series of 2D images. Maybe we should be training them on more abstracted pieces of information. Yeah, so that's one thing which is always, a question which one should look at, re-examine. I mean, there are a couple of other questions which you should look at and re-examine. I think the questions that Nitash asked were, and Kayla asked are like, sorry, I'm using your pet name. The ones that you guys asked are really very pertinent. Yeah, I'm going to stop there. Yeah.
Yeah. You're muted, Sanjeeva.
It's great to see PRK Rao, Professor PRK Rao. I mean,
I just wanted to say
I
hello
just
to
met
you.
Venki. Wonderful to see you.
Last we met in IIIT Hyderabad when you came.
Yeah, I'm in Hyderabad at the moment, and I wish I could
Oh,
have
you are
met
in Hyderabad right now? Okay. Ajay, I wanted to ask you, this chat GPT, has it shown any capacity for metaphorical speaking? For example, one of the typical capacities we have is to be engaged in metaphors. That is, instead of the literal, but we are capable of engaging with the other at the metaphorical level. Like poetry is a great instance of that. If ChatGPT has it any attempt to let it exhibit the ability to speak at a metaphorical level?
Yeah. So I think one of the things you find when you engage with it is if there is something which is on the text on the web or in books, and it has been written about and analyzed, then ChatGPT will seem to understand it. So for example, you give it a metaphorical poem or epic or whatever, it will actually tell you this is using this metaphor. This metaphor is what it is representing. You can ask it questions about the metaphor and how far it goes. It will give pretty good answers. Now, can it invent metaphors? I'm skeptical. I haven't seen it do it. But it can certainly write poetry. I've asked it to write all sorts of poetry. It can. That's sort of what I meant when I said making connections between unrelated domains. That's basically what a metaphor is, a connection between unrelated domains. It's not something it's anywhere it's good at. Basically, what I'd say is, I mean, obviously there's a level of creativity required to write any poem at all in order to write that. But the kind of creativity that involves you read a poem and you are given a new connection in your mind which you hadn't thought of before. I haven't seen ChatGPT do anything like that.
Right. That's what I thought. Particularly a novel metaphor. The ability that are currently there, currently considered to be metaphors, the ability to use them is not such a great thing.
Correct.
But to come up with a metaphor which does not exist, but it creates one, is a mark of creativity.
Exactly. I haven't seen that.
Abhay is appreciating your talk, and he has a question. Are there any non-algorithmic approaches to AI other than ML/deep neural networks? Non-algorithmic approaches to AI other than ML/deep neural networks?
Yeah, I mean, not that I know of. I mean, there used to be something we called table-driven or heuristic-driven AI expert systems, where you basically try to create a new language and then encode the heuristics which drive a particular domain, like, I don't know, medical analysis or law, into that language. And then what it will do is it will go through those set of heuristics in a database, find the right heuristic which applies to a particular situation, and answer the question based on that heuristic. Now, you can argue whether that is algorithmic or not. I'd probably say it's still algorithmic. You've just captured a database of a set of statements. You're just going through those statements, you're deciding which statement applies, and then you're answering based on that statement. To me, it's still everything you're applying a human's thinking in the end to creating that program. The key about the way machine learning does is, and why I called it non-algorithmic, is that the human doesn't know how to recognize a cat. They can't describe it to you. The way that the algorithm learns it is by looking at lots of images of cats and trees and then figuring it out by adjusting the mathematical model. So I don't know of any other, others may have an idea, but I don't know of any other way of, but it's an interesting question. Are there, that may be one of the non-foreseeable things that we talked about. What other models are there which can make software or create software without a human explicitly writing each of the algorithms?
Gopal, you have a question. You had raised your hand.
Yeah, so Pons, good talk. But when I look at, for example, all the examples where current AI is doing well or not doing well, there seems to be a very simple division for most cases. Any data or any construct generated by humans AI seems to do well. So sort of anything digital, pictures, writing, text, all that. When you go to dealing with the real world, right, that's where it seems to sort of start falling off. And partly I'm wondering whether it's our choice of mathematical representation of this whole binary and worrying about accuracy and algorithms. I just get a feeling that we need to be more non-deterministic in our math and use more fuzzy logic instead of this very precise binary. I mean, binary is great when you want a very deterministic answer. But in most of these cases, we really are not looking for a very, very 100% deterministic answer as human beings. And so so the next level, I don't think is going to come from scaling more and more and more nodes. I think there has to be a completely different way, much closer to the, I mean, our brain is analog. It is definitely not digital. I mean, even things like how the axons firing, the neurons and firing and all that. So I think it has to be more non-deterministic. I mean, for example, in the terms of scaling, there is nothing that's known about like the information capability of a given neural network, right? What can it store? There's nothing known. We just keep on adding more and saying, okay, it works better. And suddenly we see a change and we say, that's good. So anyway, that's sort of what I was thinking, more from a digital to a more analogish compute.
Can I comment on something? I don't think it is giving a binary answer, though. I mean, neural nets are producing probabilistic vectors, and we are just saying this looks like the most probable answer, and we're going with that. So it's not determined.
But the calculation is very, at the end of the day, it's a deterministic calculation.
Yes, I mean, it's doing, computation. I mean, it's doing convolutions across our entire sets of coefficients that it has.
Given the same input, it will give the same output. Correct? You get the same image, you'll get the same probability that it's a cat.
Yes.
Well, doesn't the brain follow the laws of physics and chemistry? So in that sense, this is a fundamental philosophical question. How does free will emerge from deterministic physical laws?
Yes. Professor Rao probably can talk a lot about this, but
yes.
Yeah, no, there is a fundamental difference between the analog and the digital, in the sense the analog cannot speak of itself. It's only when you develop fuzzy logic, it is rendered digital. Zade has done a great deal of work on fuzzy logic, which is instead of the binary and zero stuff, you can have almost like probabilistic assignment, but it's not quite probability. a number is assigned, which is more like a probability, but fuzzy logic Dode has developed that specifically for situations where we cannot speak in terms of precision. But the question whether I would, as a communication theorist, I would believe there is always a tension between an expression and the meaning. And insofar as there is a tension between an expression which we use to communicate and the meaning of that expression, there is a what is called a Richard's diagram, Richard-Ogden diagram, that is the symbol, the referent, and the meaning. This triangle does not collapse to a point. It's always a triangle. And that means there is always a difference between the symbol and the referent, the thing and the symbol and the referent, and the meaning you assign. Only when the three collapse into a point, you have a unique description. In ChatGPT, there is one of, I think probably is your senior probably, one K. Sriram, who posed a question in relation to some Shankara's some theory of Aham Brahmasmi stuff, and it responded beautifully. ChatGPT, but there is no metaphor there. That's the reason why I said metaphor, actually not the metaphors we use, but it creates a metaphor which appears to us as a metaphorical way of speaking. So can we think or say, ChatGPT is using metaphors, which are different from what we have so far come up with metaphors. Its ability to create metaphors is a mark of intelligence, one measure of intelligence, the way I look at it. Yeah.
Arul and Ravindra Rao have asked a question related to basically, quantum computing, which is a new paradigm gaining traction. The relationship between quantum computing and its impact that it may have on software, relation between quantum computing and software.
Yeah, it's not a big area of expertise for me, but at a high level, I mean, first of all, it's not a new emerging paradigm. It's been around a long time. People have been writing software for quantum computers for, I don't know, 30 years, even though there isn't a practical quantum computer around as yet. So it's a reasonably well explored field in terms of what are the potential capabilities of software written for quantum computers. I think the key element of a quantum computer is that it can follow multiple paths at once. And so if you have an algorithm which requires you to explore an exponential number of alternatives, the standard computer science answer is that's not a useful algorithm, because as the number of elements grow, if the number of steps grow in exponential terms, the algorithm becomes useless. It takes way too long. I mean, by the time you're up to like 100 items, you require a number of steps longer than the age of the universe. So there's no point in even trying to do it. Whereas if you could explore those alternatives all in parallel, you could actually do them within a very reasonable amount of time. And that's the promise of quantum computing. Now, in terms of practical impacts, the biggest one that I've heard about, I mean, obviously there could be a huge amount of impacts, but in terms of what's actually already happening, which is encryption. Encryption is a key part of all commerce on the internet, a whole bunch of other things where you can impersonate somebody. Is there any security on the internet at all? And in case you do have quantum computing, there are algorithms which can basically break security as soon as you have good quantum computing. So that's one practical impact. Beyond that, I don't know much about quantum.
So even on that, factoring primes is how many of these keying systems, security keying systems work. But if you look at because of the potential of quantum computing coming and becoming a reality, algorithms that are quantum computing secure have already been developed to protect security, etc. So if you look at the research, people have already kind of said, what if quantum computers happen? Is my entire security network going to go to pot? yes, if you rely on prime factorization, that's going to go to pot. But if you start implementing algorithms that are quantum computing secure, then those are the ones. And I'm no expert on this. I just I heard about them in my previous job, but that certainly happens. And in terms of preparation, I used to Microsoft and us, we would have dialogue about quantum computing. And what Microsoft told me 5 years ago was they had their entire visual stack ready to do things on quantum computer. Of course, they just didn't have a quantum computer, but the entire visual stack was ready. So in your parlance of layering, the abstractions, all the layers except the bottommost hardware layer was kind of done. Maybe some assembly based on, what the actual qubit interactions would have to be, but the rest of the higher layers they claimed were already done.
Thank you,
Sanjay, you had
Sanjay.
some other questions? Sorry.
Well, I wanted, sorry, Arul.
Yeah, I had.
Arul,
I was just thanking the speakers and Sanjay. Thank you.
Oh, sorry. So I had, again, I should download your slides at some point, but one of the things that always struck me was part of training this powerful machinery of AI and neural networks is the stuff that's still not scalable, which is if you can do things in an unsupervised learning, if you can label things in an unsupervised manner, then, the world is your oyster and go at it. But the problems that haven't been solved, I think the single most determining factor is there's no unsupervised learning. But that's the impression I have. I don't know if it's true. So if we can have breakthroughs in unsupervised learning, even plumbing, I can't imagine will remain an unsolved problem that, you will need plumbers who are and their jobs are secure. But I think it's, anyway, that's my hypothesis, and I don't know if it's true or not, but that scaling to really get models robust is essential in my mind to train it for anything.
Yeah, no, I think it's a good point.
I wanted to just jump in and just sort of reiterate the point that Gopal and points that you made in your talk, and Gopal's point that the binary abstraction, the digital abstraction that we were making was far too deterministic, and that's why the old rule-based AI, its limitations were reached very quickly. So I think we have to, the world is much more analog than is easily representable by that abstraction. And possibly, what Ravi Rao is raising, which is maybe you do need the quantum abstraction to be the right way to represent things. And maybe if you train based on those representations, you might get far more dramatic results. You may not need so many billions of parameters. You may be able to do it with far fewer parameters. I mean, a child is able to recognize a cat with far fewer examples because they've got some idea of the physics of reality. And coming to this, there was a comment about human interface or neural interface. Just a couple of days back, there was this story about being able to reconstruct based on brain scans of listening to another brick in the wall. And yesterday I was talking to a very distinguished neurophysicist here, and she said, I wish they had tried to do it on Great Gig in the Sky. Rather than another brick in the wall, you would have got many more, a much deeper understanding of human emotions. Yeah, so I mean, just sort of a joke about that.
Yeah, so
Again, to Netke's comment on gaming people, I mean, there are lots of people who have electrodes around the head and are reading brain waves and trying to interpret and do signal processing as to correlate with what the person is thinking, etc. And I haven't seen anything that's really credible to do that, except for these, one-off things that you often hear, that you can correlate things with what's going on in the brain, with starting with, it started with functional MRI, but then people wanted to do more because they could do better signal processing with multiple electrodes strapped around the head, and then try to correlate it with what things are doing. But that's all I know, and I'm sure that's of interest to gaming people, because you can put on a headset, you can put on a headset that contains electrodes, and if you can correlate it to rapid mouse movement or keyboard strokes, maybe that's all they're looking for at the moment.
So Sanjay, the development of these technologies depends quite a bit on amount of resources kind of dedicated to them. So now the game guys have experimented with nodes to the electrodes to the head for about 15 years now. Now, since then, the gaming industry is so big, it's about 3 times the size of the movie industry. There is a lot more resources being put onto it. There's a lot more money, and there's a lot more to gain. So I would expect more research on that area to develop from people like this. Now, the gaming industry has traditionally been at the leading edge of a lot of technology. Now they have much more resources than they had 15 years ago. So I would expect they will probably lead the way on a lot of these things. Now, I had another question, Ajay.
Just a minute, Sirish.
Go ahead.
Just sort of, since you were talking about movies, Sanjay had a question: can ChatGPT make movies yet?
Not ChatGPT. That's not what it is meant for. But we are starting to see other applications. I forget the specific names. Midjourney, I talked about making images. It's sort of a follow-on. I don't think Midjourney does video as far as I'm concerned, but there are similar products or companies which are starting to do videos now.
And I meant via these other, ChatGPT generates a language response, a story response,
Right.
and through vehicles like Midjourney, et cetera, or whatever the other ones are, Stable Diffusion, is it, I haven't seen any. I see stills of all kinds of bizarre situations that it can cook up, but I yet haven't seen any a movie clip that says entirely from a story written by ChatGPT converted to the semantics of instructions in Midjourney or any movie making program to do it.
Yeah.
That was the heart of my question.
I think one way I tell the state of something like this is that if it was really good, we would be seeing thousands of them, hundreds of them. So I think basically it's not there yet. I've seen 10-second clips, 15-second clips.
Oh, that's pretty good. Okay, so
Like vaguely weird. I mean, it's sort of like Midjourney used to generate like 7 fingers on the hands and things like that earlier. You get
bananas, yeah.
But it took Midjourney only a year and a half to go from 7 fingers to being exactly right. So I think it might be getting there. This may be one of those fields where, as you said, are there signs that it's about to become good?
Sanjay, I mean, going back to the gaming industry again, for about 10 years has been working on what we may call real-time generation of scenarios. So you no longer have to be in a game. You no longer pre-program the stuff in advance. It can be generated on the fly. Of course, it's very compute intensive to do that, but that is a precursor to a lot of things you can see in the future. And I would say that is the primary on which we put in the ChatGPT kind of technologies which would enhance that. So again, sorry to harp on the same topic, but I think look at the gaming industry for let's say possibilities in the future.
Is it like an Unreal Engine or something that can just take?
Yeah, so I mean, the gaming industry already has done. You go in there and you, like, let's say you're exploring one planet to another. It actually generates the scenario on the fly. Actually, Ajay knows about this because he already talked to me about it before. So, but we haven't really connected the dots between that and ChatGPT. Perhaps, Ajay, you could probably do that. The relationship between generative environments in gaming and ChatGPT.
Yeah, that's actually one of the things. I didn't talk about it in the slides, but one of the things I'm starting to wonder about is how easy is it to actually connect these different AI systems? So when we talked about algorithms and data structures, one of the things I said is that there are these libraries or these abstractions which are available to programmers. So I have an abstraction which is widgets, I have an abstraction, which is a network connection, and I can combine these abstractions to make a browser. I'm a programmer. I can take these abstractions and combine them. My impression is that that's not so straightforward in the case of AI. So, for example, it seems like ChatGPT understands poetry and mathematics and physics and all sorts of things it can have intelligent conversations about. Well, then it should be possible to connect ChatGPT over to something which basically does machinery or something which, and have ChatGPT control that. But I don't think that's actually how it works. I mean, ChatGPT basically understands probabilities of what the next word looks like. And it generates those probabilities one after the other to generate what looks like to us, like an understanding of text, of concepts. And it is generating coherent text about those. But you can't actually extract that understanding the way you can extract the understanding of UI widgets and combine that understanding with networks to create a new browser. I think this is going to be one of the challenges for AI, to use areas of expertise developed in specific areas and combine them with expertise in other areas.
No, but I'm missing some point there, because what I look at, and again, this is about abstraction, when I see ChatGPT or Bard or anybody basically being able to interface with things like Midjourney, it does not need to understand. All it needs to ingest is the semantics of what this new tool is. So, it's like I've got a library of doing things. I can ingest what that library is and essentially create fantastic looking drawings without any understanding of how anything works, except I've taught you the semantics of it.
Yeah. I mean, sort of what you're saying is Midjourney understands a language, which is English mostly, but which is this. So here's what I've seen many examples of. You tell ChatGPT to generate a detailed Midjourney instruction for how to create a drawing from much simpler instructions that you give to ChatGPT. It's basically blowing it up to a much more detailed description for ChatGPT. And that's fine. I'm still not sure it can tie it together from, in some sense, by itself. In a sense, it's similar to what Professor Rao was talking about, the creation of a metaphor versus the usage of a metaphor. I'm still not sure ChatGPT can actually drive these various other systems and make those things happen. Let's just take a simple example. Actually, Adobe is working in this area, I know, because there's recently been a bit of success in that. How do I know what I want to do with a particular image. I should be able to tell Photoshop, some kind of intelligent Photoshop, what I want. I shouldn't have to go to menus and find the right operation and be able to click and do it. And Firefly is starting to move in that direction. But on the face of it, it seems trivial. ChatGPT understands Photoshop. I should be able to give ChatGPT instructions and be able to drive Photoshop and get the result I want. Actually, you can't do it. It's been a year.
So if I say remove an object from a layer, it can't do it? Like, I have an image and
I tried to find tools which could do something like that. I tried quite a bit. I tried many. I do some 3D printing and things like that, and I use Autodesk tools for that, Fusion 360 and so on. And I'm no Fusion 360 expert. I use it only from time to time. I was hoping I could connect ChatGPT and Fusion to actually do what I want. I can't. Maybe somebody can at some point, but so far I don't see any signs of it.
Isn't it about training data? I mean, for example, the underlying language model for ChatGPT is pretty bad at answering questions and having a conversation. But a little training layer, makes it extremely good at that.
Yeah, I mean, you can ask ChatGPT how to do something in Photoshop, and it will give you instructions. It will write out the instructions required, including click on this menu item, do this, do this, do this, and so on. But that is text, right? At some point, some device has to take that text and convert it to actual instructions for Photoshop.
But isn't that an API? I mean, that, it should know how to construct an API given the rules of Photoshop, no?
An English API to Photoshop, basically.
Yeah.
Yeah, I mean, I suppose, but then that English API can't be Chat GPT. That English API is something a Photoshop team would have to write. They would have to understand English at a similar level of understanding that Chat GPT has.
Yeah.
You see, here's what I'm saying. You can't get from Chat GPT some sort of digital commands. You can get text. That's what Chat GPT does. At some phase, that text has to be translated into actually doing the thing you're talking about.
Yeah,
It
and
doesn't
if I
understand
can jump
Photoshop.
in, yeah, if I can jump in here, it has to have some traction with what you want, to converge. In traditional programming models, if you take an input-output relation and you feed it through the program again and again, you converge to the desired meaning of the program. If you start feeding ChatGPT's output to itself as training data, I don't know if you're going to converge to a better model or whether you'll get to hallucinate.
I believe there are results where AI models are trained on AI created text, and the results are terrible. They perform extremely
terrible, right? I mean, you'll start getting hallucinations because you don't converge to better.
Inputting into themselves is not a good idea, but reinforcement learning is a superb idea.
Yeah, but the reinforcing learning has to be modulated by some kind of friction with reality, some kind of traction to reality.
Oh, absolutely. And this is where I keep saying, it's like the key to me and is what can be done in an unsupervised way and what needs to get supervised, because who's providing that traction, right? And if unsupervised learning can be done, I mean, then the sky is the limit.
Semi-supervised, right?
Huh?
A language model, for example, is some sort of semi-supervised learning.
Yes.
You're giving it loads of structured data and it's learning.
Yes, but in its training, the reason we could get to ChatGPT is I don't think that required much training.
I mean, it required lots of training, but not labeled.
No, I meant human acres of asses, as one of my old bosses used to say. Did it require?
But here's Sanjay. Here's something which we should remember. Yeah. Human language as we use it is far more structured than we think it is.
Yeah.
Right. There is much more structure. And the artificial programming languages, I mean, the traditional programming languages, very tightly constrained that. Natural language loosens some of those constraints, but it's still very constrained.
But that is why I'm surprised that I couldn't write an API into Adobe Photoshop that could be taken in it's very specific instructions, and I have very specific instructions to say, and I know what to do. If I were doing this manually in Photoshop, if I wanted to remove a photobomb object, things can be done. And I'm surprised that, if I tell Adobe without ChatGPT or anything, I mean, in its own software, just remove that bicycle or remove that bastard who's sitting behind, the object of interest. But why is that so hard? That's the problem I'm.
Sanjay, about whether a bunch of people were needed for training ChatGPT, what I've read is that amongst others, at least 50 people were engaged in Kenya alone to screen all the text that was being fed into ChatGPT to take away the violent stuff and the really gory stuff. And apparently a lot of those people have now psychological problems, and they're now asking OpenAI to pay for their counseling.
Yeah, I mean, most offensive content though on social media, I think, is automated, right? Removal. Yes, some final stages, I'm sure there's screening, but I'm sure there are fairly good automated tools. I mean, I empathize with the problems of, what I don't know exactly what they were made to do, but
no, my point was that unsupervised training ought not to happen.
Oh no, the world will collapse if I don't do unsupervised.
Well, I think you're using a different meaning of supervised versus unsupervised, sort of. I think what you mean by supervised is some kind of filtering, and this is good content and this is not good content. That's not what supervised Supervised is a technical term in machine learning. The
Okay.
technical term simply means that you have lots of examples which tell the machine learning algorithm what's correct. So for example, when I talked about recognizing cats and trees, right? You have to give it a lot of images where somebody has labeled that image saying this is a cat, this is a tree. You have to give thousands of such images so that it can adjust the weights. It needs to know, I'm getting it wrong. Actually, this is a cat, but my prediction is saying it's not a cat. So I need to adjust my weights to get that right. That's what is supervised learning. It's not supervised in the sense of human filtering.
Well, even to give images, you have to first agree that these are the images of a cat. So you would have, yeah, you would have to give it 100,000 images of cats, which humans have selected, right?
Correct.
So it cannot be unsupervised in that sense. Eventually,
fair enough, but you're using supervised in a way it is not intended in machine learning.
okay, yeah.
That supervised is simply labeling that image as a cat. That's what supervision means. Whereas there are other algorithms, such as, for example, clustering. If you're trying to find human populations on some attribute, let's say, I don't know, let's say sports, and we had a discussion about this yesterday, about the performance of top athletes in, say, weightlifting. And you have a data of what is the weight lifted by top athletes. You can run an algorithm which doesn't require any labels at all. It will run an algorithm, it will create clusters. And what you might find is here's a male cluster, here's a female cluster, because they actually have different abilities to lift weights. No, that's what is called unsupervised learning. You understood that these are these two clusters without providing you any examples whatsoever.
So Ajay, I had a kind of a broader question on that area of the issue of what we call hallucination right now in ChatGPT. And it's a known problem, identified problem. The way we see it is it's a result of two kinds of, so there are two issues in the way, two problems we're trying to solve. One is that of too much or irrelevant information and incorrect information. And if your training is done on both, I mean, you're not able to converge on what you might call a correct answer. Now, if you just go back to about 20 years when the Google search or the PageRank algorithm was built, the results that we got out of that were actually pretty profound based on the situation about in 1999, right? There we did not make a distinction between I think we did solve the problem of irrelevant information. We didn't solve the problem of incorrect information. Now, fast forward to Google right now, I think it's largely useless too. It's like there is a lot of irrelevant and incorrect information in there. The question is, in the context of ChatGPT and LLM, do we see a convergence where irrelevant and incorrect information can be eliminated? Because if we don't, then this thing spirals out of control, where we don't, which has already happened in, let's say, in your traditional search. Is there anything on the LLM world where there is likely to be an improvement on incorrect and minimizing hallucinations and making, and also from the point of view of getting more relevant and more correct information?
Yeah. I think at the fundamental level, based on the design, the transformer neural network architecture, no. I mean, other than the kind of things that Saurabh was talking about, which is some humans pre-filter that information and give it only what is correct information for training. I think that's extremely hard. I mean, I don't know this specific case he's talking about, Kenya information, people doing it, but I mean, it took in something like 1 trillion pages. How many human beings are you going to assign to filter it?
But anyway, there's an analogy in that even places like Facebook as well. They hired human beings and they had the same psychological problems and the legal issues, all of that. There is a...
Yeah, but Facebook, all that people have to do is, first of all, there's an algorithm which tries to detect things which are potentially sensitive. I mean, there may be also, for example, you can write on Facebook a wrong physics theory and nobody's going to question you, or chemistry theory. It's
I'm going back to the concept. I mean, even let's say when Yahoo was started in the 1990s, they had human beings filtering.
There are human beings doing that in Facebook, but the quantum of the amount of work they need to do versus the amount of work needed to filter physics hallucination for ChatGPT is hugely different, because you're talking about all domains rather than certain political and racial and those kind of things. There's a very narrow domain that you're looking at in Facebook. If you're trying to prevent hallucinations in law or in physics, you need a much broader domain. So I think there is a process which was implemented after the basic GPT was created, which is called RLHF, Reinforcement Learning Human Feedback, where large numbers of people asked questions, were given multiple answers by GPT, and chose which one they felt was correct and which one was a good answer versus a bad answer. And I believe that's a big part of what made ChatGPT so usable and mostly correct, though of course it still hallucinates, but mostly correct. So there was a layer on top of the raw model, which was basically human beings telling it what kind of answers they like and what kind of answers they don't like.
But is there some kind of a credibility factor built into that? So for example, if they were to take that some people who are qualified experts were given more weightage than people who are, let's say, who are not experts.
I think so. I mean, ChatGPT basically employed these people. I mean, these are people paid to do this, who basically they must have selected people from various domains and said, ask all sorts of questions about your domain, and then mark out the answers about which is a good one and which is not a good one.
Ajay, what do you feel about the potential impact of generative AI on, and I'm asking as a layperson here. I was just talking a few days back to a friend. And there is a worry among the more informed social media conscious people about the potential negative impacts of generative AI in terms of, having absolutely authentic looking footage or images of let's say a politician saying something which can cause disaster. I mean, in terms of riots and things like that, especially in a place like India. So where do you see this heading? And I know it's difficult to control these things, but then governments are governments and they will try to bring in legislation, whether it works or not. And most often what happens with such legislation is that it ends up curtailing a lot of stuff which was not the original idea to curtail, and just sort of put a blanket ban on ABC.
Yeah.
So firstly, the potential for mischief, and secondly, whether it is at all possible to control, whether it's possible, for example, to have a branding and identification watermark that this is AI generated, whether it should be done like that, whether it's at all possible. And then finally, on the legislative aspects, about the regulatory aspects of trying to control such audio, video, image, footage, kind of thing, which can actually cause a lot of trouble. Any views on this?
Yeah. So technically, it's going to happen. I mean, there are already clips and audio and even some video clips out there where people are basically saying in their actual voice things which are clearly wrong. I mean, they're fake. So deep faking and the ability to create audio and video impersonating somebody else and saying something is going to happen. That's the technical element of it. I think, and the political and social impact, I mean, you mentioned potentially it can cause riots, it can cause serious issues. Now, even if we assume that there is no way around it, that there's nothing which can be done to stop it, I think it will be a phase. Because at some point, I mean, if you look at the fake news that used to go around 10 years ago, or 8 years ago, 5 years ago, the fake news today has got somewhat more sophisticated. I think there is a general understanding, at least educated people have, that anything you get on the internet could be fake. And so even if we look at our own WhatsApp groups, the amount of fake news forwarding has dropped drastically. It used to be on all the time because there's a culture which has developed that nobody believes they just anonymous message that they get on the internet, they generally don't believe. If they forward it, quite often they know it might be fake, but they forward it anyway because it serves whatever, some political purpose or other purposes that they might have. So I think obviously there can be a short-term huge problem because of this, but in the long term, I think things will settle down. People will understand that you can't believe these such videos.
Yeah, but what a layperson would say is in the long term, we are all dead, so it doesn't matter anyway. So that's okay. But the short-term potential for damage is so huge, and we are seeing that right now in Manipur, in what happened in Haryana recently, in a couple of weeks back, in those riots, and a lot of it is fake news driven. I mean, it's not that people like you and me, perhaps, yes, we do have a natural skepticism. We have developed natural skepticism. But I'm sure if you look around in your own family groups and things like that, there are still people who sort of believe everything that's forwarded to them, especially if it matches with their worldview or their set of opinions. And it is a problem. I mean, it is a real problem today. I mean, it's not that we have grown out of it. It's just that maybe you and I have got inured, and we've sort of. But along with that, getting inured is also a sense of despair, in the sense that you can't really do anything about even educating very close relatives in your own family that this is not to be trusted. This is not to be believed. So it is a problem. I mean, I agree with you that as people get exposed more and more, it's like COVID. I mean, or like any other virus, you develop a sort of a herd immunity, but which itself serves as a filtering mechanism. But the potential for huge damage is there in the interim. I mean, while it's all okay to look at the technical aspects, and that is what interests a lot of us, including me. The implication of this is really, I mean, it's terrible to even speculate about it. Really, I don't really know. I mean, I'm not asking you for an answer to this. It is just that it is something which is. Which should possibly draw more attention in terms of, because otherwise we are going to have either a selective ban or a blanket ban, or none of which is a good thing from a free speech point of view, from a democratic point of view, all that. Yeah. So you'll ultimately end up only having one sort of opinion projected all the time. Through whatever means are available. Go ahead. Sorry, I cut you off.
Yeah, so there in terms of sort of potential mitigations or preventive measures, I was saying that it will be pretty bad if nothing is done, but things are being done. Now, question is whether what is being done will be ready in time to prevent the worst of the effects of it. Who knows?
Now, is it technically possible, for example, to watermark stuff produced by generative AI, for example?
Yeah. So there are what are called content authenticity initiatives. Adobe is actually a big player in that initiative. They are driving initiative across multiple vendors, software vendors, and the hope is that they will all sign up to Adobe's content initiative, authenticity initiative, where any tools that deals with video will basically watermark the authenticity of a particular video. And then if editing is done on it, it will record what kind of editing was done and create that output. Now, that doesn't mean there will not be unauthorized tools, or even actually, I mean, today's version of the Adobe video tool doesn't do that. And so you can always keep using an old version even after the new version appears.
Yeah.
The point is, if you are looking for fake videos, then of course nobody will be able to stop you. But at least a normal person can make settings on their social media or wherever, which says, I want videos and I want to watch videos which have actually been authenticated by a known person. So just like the blue check mark that Elon Musk is putting on Twitter, which identifies a person, that this person is a paying subscriber, and there's some basic research that has been done to validate that person. Something similar can be associated with content as well. So people who want to look at authenticated content can watch authenticated content. If they are willing to look at fake content, then of course they'll always be able to do that.
Of course, I have my own opinion about that blue tick on Twitter. But in fact, some of the most prolific fake news purveyors are blue tick marked on Twitter today. So anyway, I understand and I appreciate your response.
Pankaj, I was wondering whether you're conflating this idea that technology is value neutral. Technology is never value neutral. So it depends very much on the culture in which a particular technology is deployed, the way it is utilized, whether it will constitute a fake or not. It depends very much on that. Therefore, this is a regular feature of technology. The reason why, for example, Ajay is saying that over a period of time it will vary away and you just know how to ignore in a particular kind of a culture which is constantly exposed to ever-changing technological fashions. Whereas in a country like ours, where we essentially are still colonized minds, so to speak, we get a technology and that is deployed for some purposes like this. So it is not value neutral in that sense.
Well, I'm not so sure that the same thing doesn't happen to, at least on some scale, even in countries like the US. I mean, you look at the Republicans and so on.
It happens. Even in the US, it happens. With the different kinds of technologies, it is different. But
I accept. I mean, you can use a fountain pen.
Depends on diffusion. Technological diffusion takes place. That's where we make a distinction in history in terms of whether it is migrated or it is locally generated. That has an effect. That is the reason why we make a distinction. In fact, there is a deeper problem here between the conflating. There is no way of studying history without geography, and there is no way of studying geography without history. But we made two separate departments called history department and geography department. But all historical facts are geographically constituted. So it is a larger issue, in fact, I thought. The issue that you're raising, this value neutrality of technological cultures, it's very much is not value neutral.
Yeah, it's only the speed at which news, including fake news, travels today is phenomenal.
Technology is changing so fast now.
Absolutely. Yeah.
Right.
I think if
Cyril, I saw one name, Cyril. Is it Cyril Furtado?
Yes. That was Cyril Furtado.
Oh,
he's our batch.
I wanted to. I was wondering whether it is him or not, but I think he left probably.
Yeah, he's left. I think
So
he left some time back. We can let him know, and we can see if we can. Would you like us to pass a message to him?
Yeah, I will tell him. Yeah. He and Bulgaria and they used to be pretty close to each other, and that I know.
I think Saurabh, you could probably pass a message to him.
I will do that, and if Professor Rao's phone number can be passed on, then we'll pass it on to him.
I'll pass it on to you if it's okay with you, Professor Rao.
Yeah, sure.
Yeah, I'll pass it on to Saurabh. Yeah. So if that's all, then we'll thank Ajay. I think there are 9 of us left, including Ajay.
2.5 hours.
2.5 hours. It was a really interesting.
Nice talking to you all. It's great fun after a long time.
It was an honor, sir. It was an honor to have you present, and I just took a chance and sent you the intimation this morning. I didn't know whether you would be free, but it's really great to have you.
Yeah.
And if you like, we would keep you posted on future such events. We have such an event every month.
Yeah.
We've been having it for the past about 4 or 5 months now. So I'll keep you posted. It's generally around the third Saturday or something of the month around this time.
Next one is on 23rd September. Is by Gopal Raghavan on the future of hardware.
Oh, I see. Okay, Gopal Raghavan.
So Gopal will be actually giving a talk next month.
Yeah, great.
23rd September, right?
Yes.
23rd September, Saturday again, third Saturday of the month. Right, Ajay, thank you so much. It's been great
Thanks,
talk.
thanks,
Bye,
Ajay.
guys.
This was great.
Thank you
And
all.
there are a lot of laudatory comments on the chat, thanking you for the talk, which you can go through. Thanks then. Good night. It's almost midnight
good
for
night.
people in India.
Yeah.
Just half an hour to go, and start of the weekend for people in the US. Thanks, Ajay.
Back to
Bye.
WhatsApp.
Thank you, Professor Rao.
And thank you, Professor Rao. Right.
Good night.
Good night, sir.
Yeah.